All right, let's see what the bonding looks like in a diatomic nitrogen molecule. So N2, if we draw the Lewis structure, looks like this with a lone pair on each of the nitrogens. Nitrogen is number 7, has 7 valence electrons. Let's draw the energy diagram for a nitrogen atom. First 2 electrons are going to go into the 1s orbital. The next 2 are going to go into the 2s orbital. And then the remaining 3 are going to go into the 3p orbitals. All right, so we know from VSEPR the bond angle here because well, there's 2 atoms. There's no central atom, so this is 180 degrees. Okay, so when you have a linear, when you have 2 effective pairs around these atoms, you're going to need sp. That's what you need to remember is sp hybridization. So we're going to take the s orbital in the valence s orbital in nitrogen and mix that with one of the p orbitals. Okay, and so when we do that, we're going to get a hybrid. We're going to 2 hybrid degenerate sp orbitals. Okay, right energy is right between the s and p because it's 50-50 sp character. Right, and the remaining 2 p orbitals are untouched, so we'll just relabel that up there. All right, let's put the 5 valence electrons in our new arrangement. Okay, so there we go. What is this going to look like? Let's see if we can draw this and so we can compare it to the Lewis structure. Now, NS orbital is spherical, and we're going to combine that with the p orbital, which is like dumbbell shaped. And I'm going to draw all of these kind of similar to like that. Okay, so I'm going to draw 2 of these, all right? Okay, so let's draw. I know I'm going to run out of space. I want to need more room. Okay, it's better. All right, so there's my, there's that sp orbital. I'm going to draw another one facing the other way. All right, so those 2 electrons are going to be the lone pair there. So, there it is. I'm going to draw the other nitrogen so we get a complete picture. There's my sp orbitals and my 2p orbitals. 1, 2, 3, 4. I'm going to put it this way so it's symmetrical. All right, so I just redrew another nitrogen. All right, so I'm going to draw this sp orbital now. So here's a nitrogen, if you can imagine. Okay, so I'm going to do like there. All right, so they're going to overlap, and that's going to be a covalent bond there. This is a sigma bond, by the way, because sigma bonds are along the axis between the nucleus, internucleus. So that's a sigma bond. All right. Now I'm going to draw this sp orbital facing the other way. Okay. All right, so that lone pair is over there. Now we need to make this triple bond. So we have one of the triple bonds is a sigma bond. That's what's on our screen right now. Now I'm going to use 2 different colors here. So imagine there is a p orbital along this axis. We'll call that the x-axis. Okay, and so let's say that's this p orbital overlapping with that one, right? So now this is not a head-to-head overlap, right? So that electron's there, or there, or there. It's just somewhere there. Just shade it all in there. All right, so this is not a head-to-head internuclear overlap. It's a side-to-side overlap. So this is a pi bond. Okay, so all double and triple bonds are pi bonds. First one is a sigma bond. The second one is a pi bond. All right, and then this final, let me pick a different, more contrasting color. Go with this one. All right, so that one will be, let's say, the p orbital along the y-axis. Okay, so they're going to overlap also side to side. So that's going to be our second pi bond. Right, so hope that you can compare it to this Lewis structure over there, and hopefully that gives you a good visual. All right, so one thing to keep in mind here is if you have two effective pairs, you're going to need SP hybridization.